This is Unit 5, Lesson 3, Day 5 homework, question number 10, found on page 382 of the Core Plus Mathematics Book 3, Series 2. And we are taking a look at multiplying and dividing rational functions. So we're going to take a look at this one. It says to write each of these products and quotients of rational expressions in equivalent form as a single algebraic fraction, then simplify the result as much as possible. So in the first part here, we're asked to do a multiplication problem. So we have 2x plus 4 over x squared minus 6x. We're multiplying that by x squared minus 36 over 4x plus 8. Now in number 9, I talked about simplifying everything I can first, or factoring really is what I'm applying here. I want to factor out whatever I can to see if something will cancel before I even do the multiplication or as I do the multiplication. So starting with the left, I see I have a 2 that's going to cancel out of the top, so our factor out of the top. So I can make that 2 times x plus 2. In the denominator, x squared minus 6x, I know I can factor out an x, and that's going to leave behind an x minus 6. And then we're going to multiply by the stuff on the right. On the right, I have a difference of 2 perfect squares. That's going to factor out into x minus 6 times x plus 6. And then on the bottom, I see a 4 in both of these terms, so I'm going to factor out a 4, and that will become 4 times x plus 2. So as I multiply all the stuff across the numerator and all across the denominator, I'm going to get rid of the things that are on the top and on the bottom shared. So this x minus 6 is going to cancel with the x minus 6. The x plus 2 is going to cancel with the x plus 2. And the things that I have remaining, I have a 2 on the top and a 4 on the bottom. I know that 2 can cancel off with one of the 2's in the bottom, but I want to change this 4 to be now a 2 because I put in a 2 instead. In fact, if previously, if you're looking at just the answer solutions, it wouldn't make sense to write 2 times 4. So I'm going to write this as 2 times 2. I'm going to cross off one of those 2's as the product there. So it's going to leave behind for us an x plus 6 in the numerator. And in the denominator, we have a 2 and an x. Now we have to do a couple qualifiers here. X cannot equal 6. And we don't want x to equal a negative 2 either. Those are the two values that we have eliminated, which would end up as holes in the graph here, or at least where the function is undefined, if we're not talking about graphs. So in part B, we have another expression, x minus 3 over 7x being multiplied by a 3x squared over x squared minus 2x minus 3. So we're going to factor where we can. Nothing to factor on the left side. On the right side, this quadratic in the bottom, we're going to take a look at factoring if it's possible. So I'm going to just rewrite what we have on the left and have that multiplied by the top. Now I could write this out as x times x, so I think I will. And then in the bottom, I'm looking for things that multiply to a negative 3 that will add to a negative 2. And so I'm kind of thinking, well, I'm going to have x minus 3 times an x plus 1. Negative 3 plus 1 is a negative 2, and negative 3 times 1 is a negative 3. So on the bottom, we'll have x minus 3, and we'll have x plus 1. And so we'll actually see a cancellation of the x minus 3 from the top and the bottom, and we'll see an x go from the top and from the bottom, and we're left with a 3x on top, and on the bottom we have a 7, and we have an x plus 1. And we have to give it a couple qualifiers. We know that x cannot equal 3. We also want x to not equal 0 to be equivalent there. And then in part C, we have our first division problem, and so we have x squared minus 4 over x squared plus 2x minus 5 being divided by x plus 2 over x squared plus 2x minus 5. And again, we're going to treat this like we did the division problems in number 9. We're going to reciprocate the second expression and then multiply. So I have x squared minus 4 over x squared plus 2x minus 5 times x squared minus, or plus 2x minus 5 all over x plus 2. And hopefully you're seeing what I'm seeing. X squared plus 2x minus 5 on the top, and x squared minus 2x minus 5 is on the bottom. So that whole expression gets canceled off without even having to worry about factoring. I do want to factor x squared minus 4, though, because I see an x plus 2 on the bottom, and I know this is a difference of perfect squares. That will factor into x plus 2 times x minus 2, and then the bottom we'll have x plus 2, which will then cancel out the x plus 2's, and this whole expression simplifies down to x minus 2 with a couple of qualifiers. We do not want to let x equal a negative 2, but then we do have to go back to the x squared plus 2x minus 5 and figure out where would that equal 0. Well, it's not a real great expression if we have x squared plus 2x minus 5, we'd have to look for the things that multiply to a negative 5. Well, there's only two numbers that multiply to 5, 1 and 5. And when one of them is negative, neither one of them is going to add to a positive 2. So this isn't going to factor nicely over the integers. That doesn't mean we can't approach this problem and come up with a 0 still. What I might recommend is, remember, completing the square piece. I can take this part to complete it is x plus 1 squared, but squaring 1 would give us 1, and we're short 1 and we're short 5 more, so that'd be subtracting 6. Set that equal to 0. Then I know that x plus 1 squared equals 6. I can then root that to have x plus 1 equals plus or minus the square root of 6, and then subtract the 1. So we also cannot let x equal plus or minus the square root of 6 minus 1. That's really something that we can't make an integer out of, but that's okay. It's still applicable. We still should consider that as an option. We can't let the bottom part go to 0. So that's taken care of there in part C. Let's look at D, the last one on the expressions here. 2x squared plus 10x over 4x plus 10 is being divided by the other expression, so we're going to multiply by its reciprocal, 9x plus 3 over 3x squared plus x. And now we're going to simplify this by factoring every part that we can. I see an x and a 2 that will factor out of the 2x squared and the 10x. So that's going to become 2x, and that's going to be times x plus 5. And on the bottom, I'm going to factor out a 2 as well to get 2, and then on the bottom we'll have x plus 5 there. Okay, and then we're going to multiply that by the 9x plus 3 can factor out a 3, so we'll make that 3 times 3x plus 1. Over on the bottom there, we'll factor out a 3x, which will leave us with x plus 1. Okay, and now we'll take a look at, and we'll think about what we can cross off and what we can't cross off. What we'll see on the left is that the x plus 5 goes away. That's kind of nice. The 2's go away. And then on this side, I see an x on top, and I see an x on the bottom over here. Those can go away. The 3's can go away over here. So I've gotten rid of everything on the left and only leave a 3x plus 1 on top, and I leave an x plus 1 on the bottom. Now be careful here. Don't cross off the x plus 1, because this 3 in the front is a multiplier of just the x. It's not 3 times the quantity x plus 1, so it's not x plus 1 is not a factor. It's 3x and then it's add 1, and this is a positive 1x and an add 1. These are not equivalent to each other by a given ratio of 3, so it stays that way. We do want to put our qualifiers in. X cannot equal a negative 5. That was giving us a 0 out, and we also cannot let x equal 0 for those expressions. And the constants, however, don't really affect the domain, so we don't need to worry about those. And that's the end of question number 10.